Good morning, dear students. Yes, good morning, Harshita. Okay, so in the previous class, what we were discussing about the factors, right? We had discussed about the factors which affects the rate of reaction. So which are the main four factors which are affecting the rate of reaction? So the rate of reaction, it depends upon the concentration of the reactants, temperature, okay, then the catalyst and nature of reactant, right? So how these factors, how they affect the rate of reaction. So these things we have seen in the previous class. Also, then we had started with the order of reaction, right? What do you mean by order of reaction? Right. So what is order of reaction? Okay, how to write the rate law expression. So we have seen how to write the rate law expression. Then, then we have seen what is the order of reaction. What is order of reaction? It is defined as the sum of the powers. Okay, it is defined as what? Sum of the powers to which the concentration terms are raised. Okay, concentration terms are raised in the rate law expression to express the observed rate of the reaction. So, this rate expression, it is experimentally determined. Okay, it is experimentally determined. So the power of the concentration terms in the rate law expression, it is called as the order of reaction. Right. So these things we have discussed in the previous class. So we know that order of the reaction can only be experimentally determined. Okay, and it cannot be predicted. So whenever any chemical reaction is occurring, you cannot predict the we cannot predict the chemical reaction, but what it can be determined experimentally. Okay, so the order of reaction, it can be 0, it can be 1, it can be 2, 3, or it can be a fractional number and also a negative number. Okay, so this is about order of reaction. So we know now how to calculate the order of reaction. In the previous class, the students who have missed the previous videos, okay, so these videos are saved, okay, in the YouTube. So you can go to the YouTube, okay, and there you can find in the page, okay, of Sankalp Learning Solutions. So there you can find this previous whoever have missed it, so please go through this videos. Okay, so next, then we had seen the units of rate constants. Okay, so what are the different units? So we have seen how to find the order of reaction. Then also we have seen what are the units of rate constants, or that is of zero order, first order and second order, right? Then we had started with molecularity of reaction. What do you mean by molecularity of reaction, students? Yes. So molecularity of reaction is what? It is a chemical reaction taking place is only one step. Okay. It is the chemical reaction that take place in only one step. Okay. And here it is called as the elementary reaction. If the reaction is proceeding through many steps, okay, then it gives rise to what? It gives rise to complex reaction. Okay, so in complex reaction, it involves what? It involves the mechanism. Okay, now we have seen in your haloalkenes, haloarenes, right? SN1 reaction. In SN1 mechanism, okay, there are two steps reaction. Okay, there is a two-step reaction. So the reaction will not proceed in one step, but the reaction will proceed in two steps. When the reaction proceed in two step, okay, so that time the first step is a slow step. So first step is a slow step, and this slow step, it is called as the rate determining step. What it is called as? It is called as the rate determining step. Okay, or it is the order. So it or this particular slow step, it decides the order of reaction. Okay, what was the first step? It is the formation of carbocation, right, in case of SN1 mechanism. Then second step is what? It is a fast step. So attack of the nucleophile takes place at the carbocation. Okay, so this is an example what I'm giving you. So whenever a reaction is proceeding in single step, such reactions are called as elementary reaction. And whenever the reactions are proceeding more than one step, okay, then it will give rise to complex reaction. So that time what will happen? There will be a mechanism of reaction will be involved. So mechanism will be involved in that particular reaction. Okay. Now, so what is this molecularity? Okay, what do you mean by molecularity? Molecularity means what? Okay, molecularity means the number of reacting species. Okay, the number of reacting species means how many reacting species means what? Yes, now we know that reactant will be on the left hand side and the product will be on the right hand side. So the species, okay, the number of molecules. Okay, how many molecules or how many atoms or how many ions are present. Okay, how many molecules, how many atoms, or how many ions are present at the reactant site? Okay, so so what will happen? They will collide with each other and they will bring out a chemical reaction. So the molecularity depends on what? It depends upon the number of reacting species. Okay, and this molecularity of reaction. Okay, so it cannot be zero. It cannot be zero. It cannot be fractional. Okay, it cannot be fractional or it cannot be negative. Okay, the value, it cannot be zero, it cannot be fractional, or it cannot be negative. It can have a whole number 1 2 and 3. Okay, 1 2 and 3, like that. So molecularity, so can you make out the difference? Order of reaction and molecularity of reaction. Order of reaction, yes, it decides the what? It decides the, so how many, the sum of the powers of the concentration terms, okay, of the reactants in an extremely determined rate equation. So what is the powers? Okay, so we are adding the powers. Suppose we had seen, so rate is equals to, okay, we have seen this, so rate is equals to A into 1 by 2 and B into 3 by 2. So this is a rate equation. Okay, rate expression. Now how we find the order of reaction? We are adding the sum of these powers, right? So 1 by 2 plus 3 by 2, how much it will be? Yes, it will be 1 plus 3, so it will be 4 by 2, so it is 2. So the order of reaction is 2. Now molecularity means what? Molecularity means how many molecules, how many atoms, or how many ions are involved, how many reacting species are involved. Okay, how many reacting species are involved. So this will tell you the molecularity of reaction. Okay, now here, can you see these examples? Yes. So these are the examples. Now here, the first example is what? PCl5. Okay, PCl5 means what? Phosphorus pentachloride. Okay, phosphorus pentachloride. So what is happening? Phosphorus pentachloride is giving you, okay, it is undergoing a decomposition reaction. Decomposition means what? It is breaking down. Okay, PCl5, it is breaking down to give you what? It is giving you PCl3 plus Cl2 plus Cl2. Okay, so PCl5 is, it is undergoing a decomposition reaction to give you PCl3 plus Cl2. So how many molecules are involved here? How many molecules are involved? Only one molecule of PCl5 is involved, right? Can you see any number here? Can you see any number? No. So it means one molecule of this. So this is a unimolecular system. Okay, this is called as what? Unimolecular. Okay, it is called as unimolecular. Second example, go to second example. Okay, so this is clear, I hope. Okay, let us go for the second example. 2Hi. Okay, 2 moles of hydrogen iodide giving you H2 plus I2. Okay, this is also undergoing a decomposition reaction to give you H2 plus I2. So how many moles of hydrogen iodide are reacting? Yes, 2 moles, right? So it is a bimolecular system. You know, when it is 1, it is uni. When it is 2, it is called as bimolecular. When it is 3, it is called as tri-molecular. Okay. So how many moles of HI is involved? Here, 2 molecules of HI is involved. Okay, 2 molecules of HI is involved. So it is a bimolecular system. Now, third example. Okay, go for the third example. What is the third example? NO. okay, plus O3, giving you NO2 plus O2. Okay, so now if we see the number of moles, so here how many numbers is there? It is 1. Okay, no number means you have to consider it as one molecule of NO. Here any number, no number. So it is also 1. So 1 plus 1 is 2. So two molecules, right? So two molecules or two reacting species are involved. So again, this is a bimolecular system. What it is? A bimolecular system. Let us go for the next one. 2SO2 plus O2 giving you 2SO3. Okay, let us count the number of molecules reacting species involved. How many numbers? It is 2. Okay, plus how many molecules of O2? No number. So it is considered as 1. So 2 plus 1 is equals to 3. So 3 molecular reacting species are involved. So it is a trimolecular. It is called as what? Trimolecular. Okay, let us go for the next one. 2CO plus O2 giving you 2CO2. Okay, 2 that is carbon monoxide plus oxygen. When it combines, it gives you what? 2 carbon dioxide. Okay, 2 moles of carbon dioxide. So can we calculate? Yes. See here how many molecules are there? Here 2 molecules of carbon monoxide and 1 molecule of oxygen. So 2 plus 1 is 3. So again it is a trimolecular system. Okay, it is a what? It is a trimolecular system. Okay, let us go for the next one. So 2FeCl3, okay, ferric chloride. Okay, ferric is in plus 3. So when Fe is in plus 2 state, it is called as ferrous. Okay, it is called as ferrous. Now FeCl3, right? Each Cl is minus 1, right? So there are three atoms of chlorine. So it is three minus 3. So each, this is how much? Sorry, there is 1, right? So this is plus 3. So plus 3 minus 3, the whole charge will be 0. So this is called as ferric. So whenever the iron is in plus 3 state, it is called as what? It is called as ferric. Okay. And when the iron is in plus 2 state, it is called as ferrous. Okay. It is called as ferrous. So ferric chloride in the presence of tin chloride. Okay. Tin chloride gives you tin chloride plus FeCl2. Okay, tin chloride plus FeCl2. So let us calculate the number of molecules involved. Okay, so 2 moles of FeCl3 and no number means it is considered as 1. So 2 plus 1 is 3. So 3 number of reacting species are involved. So it is a trimolecular system. So this is about molecularity. So is it clear about molecularity and order of reaction? Yes. So example will be given. Okay, how the question is asked. Example will be given and they will tell you to find the molecularity, or example will be given and they'll ask you to find out the order of reaction. Okay. Okay, fine. So let us see now what is the difference. Okay, important, very important question. Okay, let me take a blank space. Is there? Okay, it is there. Hmm. So very important. Mark this as important, students. Okay, mark this as important. So the difference can be asked. Difference can be asked. What is difference? Or they'll give differences between order of reaction and molecularity of a reaction. So like this, the question is asked. Give the difference between order of reaction and the molecularity of reaction. Is it clear? So like this, the question is asked. Okay. So what is order of reaction? So it is the sum of the powers of the exponents or the concentration in terms of rate law expression. So you have to write the definition. So if you write the definition as a first point for order of reaction, then for the molecularity also you have to write the definition only. So what is molecularity of the reaction? It is the number of reacting species, that is the number of atoms, ions, or molecules that must collide with each other, that will collide with each other to form products in a chemical reaction. Okay, so this is a definition for the molecularity of the reaction. Okay, this is the definition for molecularity of reaction. Okay, so this is the first point. Okay, so in both the case, what you have to write? You have to write the definitions for both. Then the order of reaction in it can be fractional as well as zero. We have seen this, right? So order of reaction, it can be a fraction also. Okay, what do you mean by fraction? 1 by 4, 3 by 2, 1 by 2. Okay, so these are the fractions. Yeah, right, you know this. So fractions, so the order of reaction, it can be fractions. But order of the molecularity of reaction, it is not fraction. So it is not, okay. It is not, the molecularity of reaction cannot be a fraction. Order of reaction can be zero. Okay, it can be zero also. But molecularity of reaction, it is not zero. Okay, it is not zero also. Then the order of reaction, it can be determined experimentally. Okay, so order of reaction, it can be determined experimentally. Then your this what? Hmm. Molecularity of reaction, it is a theoretical concept. Okay, it is a theoretical concept. Got it? So what is order of reaction? Order of reaction is a experiment. It can be determined experimentally, but molecularity of reaction, it is determined theoretically. Okay, theoretical concept. It is based on the theories. Okay. Then next is what? Order of reaction. It is applicable for elementary as well as complex reaction. Now you know what do you mean by elementary means the reaction takes place in single step. Elementary means the reaction takes place in single step. Okay. So the reaction, when it takes place in single step, it is called as a elementary reaction. And what do you mean by complex reaction? When the reaction takes place more than one step. Okay. So in complex reaction, what happens? Mechanism takes place. We have seen in case of SN1 mechanism. Is it clear? Yes. So elementary means the reaction takes place in single step, and complex reaction means what? The reaction takes place more than one step. Okay. Suppose if I consider SN1 reaction. In SN1 reaction, what happens? The reaction takes place in two steps. First one is the slow step. Second one is the fast step. So in any so whenever a complex reaction is there, so that time it will follow a mechanism. In that mechanism, it will undergo the different steps. So one of the step will be a slow step, and that slow step is called as what? Rate determining step. So these things you have to know. What is elementary reaction? Elementary reaction is a reaction which takes place in single step. Okay, clear. What is complex reaction? When a reaction proceeds more than one step, then it is called as complex reaction. In complex reaction, it gives rise to mechanism of the reaction. In mechanism, okay, so they will follow a different step. So in one of the step will be a slow step, and that slow step, it is called as the rate determining step, and that will decide the order of reaction in case of complex reaction. Now in elementary reaction, as it is proceeding in one step, so that will only decide the order of reaction. But in complex reaction, if it is undergoing more than one step, then one of the step will be a slow step, and that slow step is what? It is a rate determining step, and that step only will decide the order of reaction. Is it clear now? Yes, very important point. Okay, is it clear, students?
Yes, ma'am.
Okay. So, in order of reaction, what happens? It is applicable for both elementary as well as complex reaction. And molecularity of reaction, it is only applicable for elementary reaction. Okay, it is elementary. It is applicable only for the elementary reaction. Okay. Then we have also seen that negative order of reaction is possible. Okay, your order of reaction can be zero, it can be one, two, three, it can be a negative number, it can be a fraction. Okay, but of molecularity of reaction, it can be only 1, 2, and 3 whole numbers. It cannot be zero, it cannot be a fraction, and it cannot be a negative number. Okay, then again, so the type of reactions depending upon the order. So whenever the order of reaction is given, so depending upon the so type of reaction, okay, the order can be given as zero order, and it can be a first order. Okay, and all the radioactive elements, they will undergo disintegration reaction. Then depending upon the reaction, okay, when it depends on molecularity, so it is given as unimolecular reaction and it is given as bimolecular reaction. So these are the types of reaction. Is it clear? So the differences, mark this as important. Okay. Please note these important points. So what you can do, this and this you can combine as one only. Okay. So it can be what you can write. It is always a whole number. Okay. That is 1, 2, 3. Sorry, order of reaction can be zero as well as fraction. Okay, but molecularity of reaction, it cannot be fractional or zero. Then order of reaction, it is a negative order is also possible. In molecularity of reaction, it cannot be negative. Okay, like this, the differences should be given. On the both side, when you are writing definition here, here also you have to write definition only. When you're talking about fraction as well as zero, you're also you are going to give the same difference. Means what is the difference of molecularity with respect to fractional and zero. So that, so how it is determined here, it is determined experimentally, it is determined theoretically. So this is applicable for both elementary as well as complex. This is applicable only for the elementary reaction. Okay, so like this, you have to give the differences. Very important question. So they will ask, give the differences of order of reaction and molecularity of reaction. Okay. So depending on this order of reaction and molecularity of reaction, let us solve problems. Okay. Let us solve the problems. So this is the first problem. The rate of reaction, the rate of reaction increases 4 times when a concentration of reactant is doubled. Okay, what is the order of reaction? What is the order of reaction? So please note the question. The rate of reaction increases 4 times. What I'll do, I'll shift these two questions separately. Okay. Okay, let us solve this first one. The rate of reaction increases 4 times when the concentration of reactant is doubled. What is the order of reaction? So what is said? So rate, we know that rate is directly proportional to the reactant, right? So we have seen this, how the order of reaction depends upon the rate, right? When we are talking about rate of the reaction, what is rate of the reaction? Yes, when we talk about the reactants, the factors affecting the rate of reaction. So how the, just a second. Here it is. Right. The nature of reactant, right? So the reactivity of a substance is related to the ease with which its specific bonds are broken. So the oxidation, so it depends on what? It depends on the nature of reactant. Okay. So the nature of reactant plays an important role. So when we are talking about, so how is rate associated with the uh, this what? Reactant, it is directly proportional. Okay. So it depends upon the rate. So it is directly proportional to the reactant. Okay. And the exponent is given as X. So how we write the rate expression? So the rate expression is given as R1 is equals to K into, okay, reactant R into X. So let us consider this as 1. So when the concentration of the reactant is double. So this is with respect to a simple rate. Okay, a rate reaction is undergoing. So now when we are, so let us consider the next step. So when concentration of when concentration of reactant when concentration of reactant is doubled. Okay, when the concentration of reactant is double, what will happen to rate? Rate also increases by 4 times. Okay, it will increase by 4 times. Fine. So how the rate will increase? So it will increase 4 times. So that is okay, 4R1. 4R1 is equals to K into 2Rx. So this is the second equation. So if we divide 2 by 1, okay, if we divide, so divide 2 by 1. So how you will get? Just see what you will get. So 4R1 is equals to K into 2R into X. Okay, divided by R1. Okay, divided by K into R raised to X. So after dividing, R1 and 1 get cancels. K get cancels. Right. R and exponent get cancels. R and exponent get cancelled. So it is 4 equals to 2 into X, right? This is equals to 4 is therefore 4 is equals to 2 into X. So therefore 2 into 2. What is 4 is nothing but 2 into 2, 2 square, right? That is 4. So that is 2 is equals to X. So X is equals to 2. Yes. So the order of reaction is 2. So the rate of reaction increases 4 time when the concentration is doubled, right? So this is the rate. We know that rate is directly proportional to the reactant, right? Exponent of reactant. Now, when the reactant is double, okay, what is the condition? The reactant is double, okay, and the rate of reaction increases by 4 times. So 4R1 is equals to this. So after relating, you will get the order of reaction as 2. Is it clear? Yes. So like this, the question can be asked. Okay, fine. Okay. Let us go for the next problem. A reaction is second order with respect to reactant. How is the rate of reaction affected if the concentration of the reactant is doubled or it is reduced to half? So there are two conditions now. So the reaction is second order with respect to reactant. Okay. So let us write the reaction. So the rate, so what is given? So it is given as rate is directly proportional to reactant. Okay. So and it is a second order reaction. So the exponent will be equal to 2. Okay. So that is how we write the rate law expression. R1 is equals to K into R square. Okay. R is to 2. That is nothing but your, it is a reaction is second order. Okay. So first condition is what? What is the first condition, students? When when concentration of reactant is doubled, is doubled. Okay. What will happen to rate? Rate will be, so what will be the rate? Okay. Fine. So let us see. So rate will be what? R2 will be equal to K into 2R square. Right. So what we'll do? So R2 will be equal to K into 2 square dot R square. Okay. So this is when we are multiplying. So the rate constant, okay, we have just multiplied the into the brackets. Okay. So K into 2R square. So we have just opened up the brackets. Now, what we'll do? We will divide 2 by 1. Divide 2 by 1. Just see how much you're getting. So R square is equals to K into 2 square into concentration of R square upon R1, and this is K into R square. Okay. So what all factors will get cancelled? So K will get cancelled and this will get cancelled. So R2 will be equal to 2 square is 4 into 2 square or, and this will R1 will move this side. So it will be R2 is equals to 4 into R1. So what will happen? Therefore, I'll write here. Therefore, okay, rate increases by 4 times. So when the reaction is a second order, when the reaction is a second order, okay, what will happen? The concentration of the reactant is double. The rate will increase by 4 times. Okay, the rate will increase by what? 4 times. Is it clear? Yes. Okay. So next one, second one. Okay. So when concentration of reactant, when the concentration of reactant is reduced to half, is reduced to half. Okay. What will happen to rate? Rate will be, yes, let us see. So R3 is equals to, okay, K into R by 2 square, right? So when the rate is what reduced to half, so R3 is equals to K R square, okay, and 1 by 4, right? So 1 by 4, it can be written as R square by 4, or I'll write it here, K by 4, okay, K by 4 into R square. So this is our second, sorry, third one, no, your first, second, and third one, okay. Now what we'll do, divide 3 by 1. Okay, divide 3 by 1. Let me write it here. Okay, divide 3 by 1. So R3 by R1, R3 by R1 is equals to R3 is what? K by 4, K by 4 R square. Okay, and what is your R1? K into R square. Okay. Now just see what all you will get cancelled. K and K will get cancelled. R square and R square will get cancelled. So R3 is equals to 4 into R1. So rate increases by 4 times. Rate decreases by 4 times. Okay. Rate 4 into R3. So R1 is equals to, so your R3 is equals to, so R3 is equals to, if I shift this 4 here, it will become 4 R3 is equals to R1. Right. So what will happen? Yes, 4R3 is equals to R1. So what will happen to the this? It will decrease. Okay, so if the concentration of the reactant, okay, if it is reduced, if the concentration of the reaction, if it is reduced, okay, of the reactant is reduced to half, then what will happen? It will decrease. So rate will decreases by 4 times. Rate decreases by 4 times. Okay, because this is R3 is what? R3 is, first of all, you have reduced it. So R1 is, if, okay, R1 is the main reaction, right? So that is rate is directly proportional to the react. So if the rate decreases, if you have reduced it to half, then it will decrease 4 times. Okay, it will decrease 4 times. So this is the with respect to how the reaction rate of the reaction is affected if the concentration of the reactant is double or reduced to half. Okay, is it clear? Very important. So like this, the question can be given. Okay, whether the reaction, okay, how it is affected. So like this, the question will be given. Okay, one more question. We have one more question. A reaction is first order in A and second order in B. Okay, write the so a reaction is first order in A and second order in B. Write the differential rate equation. First question. Second one, how is the rate affected on increasing the concentration of B 3 times? And how is the rate affected when the concentration of both A and B are doubled? Okay, so 3 questions are asked. First is what? First question is, so let us, okay. So what is the first question? First question is write the differential rate equation. So the reaction is first order in A and second order in B. Okay. So how it will be? So with how to write the differential rate equation? So minus dr by dt. Okay, dr by dt is equals to rate of. So the what is the reaction of order rate is first one is A. That is A. The reaction in first order it is A in first order and for B it is a second order. So this is a differential rate equation or it can also be written as differential rate equation. Rate is equal to rate is equals to K into A raised to 1 and B raised to 2. That is R1 is equals to K into A raised to 1 and B raised to 2. So this is the first. Okay, so this is the first question. Got it? So this is the first equation of the differential rate equation. Okay. Now second one. So this we have completed how to write the differential rate equation. Second one is what? When the concentration of the B, okay, if it is increased 3 times. So when concentration of B is increased by 3 times, increased by 3 times, then rate will be, what will be the rate? Okay. So let us write. So R2 will be equal to K into A1 by, so what is happening to concentration of B? 3 into B square. Okay. So this is the concentration of B. Now what will happen? So R2, so let us multiply this. So 4 in K into A raised to 1. So 3 square. Okay, and B square. So this is the second equation. Okay, now what we'll do? Divide 2 by 1. Divide 2 by 1. So what we'll get? Yes, students. So R2 is equals to K A raised to 1 dot 3 square 3 square into B square divided by R1 divided by K into A raised to 1, B raised to 2. Okay. Cancel. So K get cancels. A1 get cancels. B square, this get cancels. So R2 is equals to 3 square is 9 into R1. So therefore, what will happen? R2 is okay. So if the concentration of B is increased by 3 times, then the rate will be what? It is 9 times. Okay. So it will be 9 times R1. So it will increase by 9 times. Okay. It will be increased by 9 times. Okay. Let us see next question. When concentration of both A and B is doubled, then rate will be. So the next question is what? If the rate is affected when the concentration of both A and B are double. So we are doubling both. So R3 is what? Next equation R3 is equals to K into 2A raised to 1 and 2B raised to 2. Right. The order will remain the same, only the concentration of the reactant we are increasing. So R3 is equals to K into 2 to 2, okay, into A1 dot 2 square B square. Okay. Divide. Now this is equation number 1, 2, and 3. This is equation 3. So divide 3 by 1. Okay. So R3 is equals to 2 into A raised to 1, 2 square B raised to 2. Okay. So this is R1 and here it is K into A raised to 1 and B raised to 2. Just see, is it clear? Okay. So here it is. Cancel now. Similar terms, K get cancels, A1 get cancels, B square get cancels. So how much it will be? So R3 is equals to 2 into 2 square is 4, R1. So it is R3 is equals to 4 to the 8 times 8 1, R1. Got it? So like this. Is it clear? Yes, is it clear now?
Yes, ma'am.
Hmm. Okay. So like this, the questions can be asked. Okay. So how is the order of reaction determined? So like this, the question can be asked. Okay. Let us go for the next one. Okay. So this completes our 3 questions. Okay. So then and there itself, I am solving the question. Okay. So that it will be helpful for you. Okay. So next we are going to study the orders. Okay, next we are going to study the order of reaction. So first one is the zero order reaction. First one is what? Zero order reaction. Now what do you mean by zero order reaction? A reaction in which the rate of the reaction is proportional to the zero power of concentration. Yes, please note the definition. So what is the zero order reaction? Yes. Okay. So what is a zero order reaction? Yes, zero order reaction is a reaction. Okay, a reaction whose rate of reaction is proportional to the zero power. Okay, so the rate is given as the concentration. Okay, the rate of reaction is proportional to the zero power of concentration of the reactant. So such a order is called as what? Zero order reaction. Got it? So zero order reaction. So the reaction in which the rate of reaction is independent of concentration of reactant. So these two definitions are called as what? Zero order reaction. So what is a zero order reaction? Okay, so the rate of reaction is independent of the concentration of the reactant. Or it can be also said as that rate of reaction is independent of the concentration of the reactant. Such reactions are called as a zero order reaction. What can be an example? The example I can give you of decomposition decomposition of ammonia. Okay, decomposition of ammonia at the surface of metals like your platinum, gold. Okay, so this is an example of a zero order reaction. So suppose 2NH3, okay, in the presence of platinum at a high temperature 1130 Kelvin gives you N2 plus 3H2. So this is a reaction of a zero order reaction. So it is independent of the concentration. It is independent of the concentration. Okay, it is independent of the concentration. So it is a zero order reaction. So the decomposition of ammonia at the surface of metals like the platinum, gold, etc. Okay, so this is an example of zero order reaction. So how is the rate given? So rate is given as K into NH3. Okay, that is raised to 0. So it is independent of the concentration. It is independent of the concentration. So rate is given as that is the concentration of the reactant, which is a reactant ammonia. So concentration is independent of the reactant. So such a reaction, it is called as what? Your zero order reaction. So if you plot a graph, okay, if you plot a graph, so how is the nature of the so how is the nature of graph? Okay. So if you plot a graph of rate, okay, versus concentration, so you can see you will get a straight line. Okay, you get a straight line. So as the rate increases, okay, the concentration also increases. So as the rate increases, concentration also increases. So this is about your Okay, this is about your what? Rate versus time graph. Okay, so we know that how is the rate given? Rate is equal to minus dr by dt. Okay, so that is it. K is equals to r is to naught. Okay, so we know that rate is directly proportional to the what? It is directly proportional to the constant, right? So rate of the reaction is directly proportional to the rate constant, right? So if we compare this straight line equation, it is as equal to y is equals to c. Okay, so the this reaction, this graph, it represents what? It represents, you can see y is equals to c, right? So this is about your zero order reaction. Okay, now here so this second graph, when we'll plot when we'll see the expression, so that time we'll see. Okay. So what is the example of zero order reaction? The zero order reaction is some of the enzyme catalyzed reaction, and the second reaction is 2NH3, that is a decomposition of ammonia. 2NH3 giving you N2 plus 3H2. Okay, in the presence of platinum and 1130 Kelvin. Is it clear? Yes, is it clear? So next we are going to we are going to write the expression for rate constant, that is the integrated rate equation of zero order. Okay, so that will take much time. So let us start this in the next class. So till whatever I have told today about the order of reaction, molecularity of reaction. Okay, then we have discussed some of the problems. So please go through these all things. Okay, in the next class, we are going to see the very important. Okay, so from this chapter, they will ask you the integrated rate law expression. Okay, for either zero order or first order. So for 3 marks. Okay. So let us see that in the next class. Any doubts up to here? Yes, any doubts up to here? If you have any doubts regarding today's session, you can ask. Okay, so the same time, so the same time the classes will be there for chemistry. So, okay, henceforth it will be the same time, that is from 7:45 to 8:45. So please attend the classes. Don't miss the classes. Okay, if you miss one class also, it will be very difficult for understanding the previous concepts. Okay, so please be regular for the classes. Okay, yes. Other students, any doubts? So whenever the things are told, so that day only you just revise it, okay? So that it will be more helpful. So if you have any doubts while revising, you can come to me in the next class with your doubts, okay? So you can ask your doubts in the next class. Yes. Anything you want to ask? Yes. Okay, fine. Who all are there? Navneet, Charan. Yes. Boys, any doubts? Okay, fine. Okay then. So we will end the session here. Yes. So we will end the session here. Okay. We'll meet in the next class. Thank you. Have a good day. Yes.